Hey everyone, good afternoon. Previously, I have a post talking about the count function. So we want to explore the different result from the count function in the SQL environment. So here on my screen, I have opened this Snowflake data warehouse environment. I just registered that it was a free account. You can use that with 30 days. In this trial period, you can explore the full taste of Snowflake. Here we have a simple data set, and also under that we have a table called duplicates. So if we run this query to have a look of this table, the table is looking like this way. So we have 9 rows, 2 columns, column 1, column 2. Each of the column, they have some numbers. And most importantly, some of the rows, they are actually null. Null is a special term for the data. Means there's no presentation of data itself. So it's like a void. So we not only have those null values under the column 1, but also we have that under column 2 as well. So let's just explore the function count function, how it's going to return a different result based on the scenario or the case or the term that we're using. Okay, so let's just jump back to this left-hand screen. On left-hand screen, I have this naked run. So within this naked run, I wouldn't provide any, for example, hint about what I'm trying to do, but also we're not providing those solutions. So in this case, what I try to do is we try to think about the result of each of the count. So each of the count is actually forming a column, and that column will be the name of these whole terms if I don't use alias. And the table I'm using is the duplicate, which is the same as I have over here. So 9 rows, we're not doing the count. So let's just inspect the first one. First one is count star. You may have already know what star does, but it may out of your knowledge in this case for the count situation. So we will talk about that later. Second column is count base. Right now I'm using a base as an alternative name of our duplicate table. So that's why base full stop star. We all know that if you use alias, full stop, and star, that star means every column. So we'll see what's the result of that later. And the third part, we're trying to count on a single column. This single column, we can choose column 1 or column 2. We won't know the result. The next one is we're going to count based on if we add a prefix, like say the alias name base. And this part, we're trying to say, okay, we have finished the count of one single column. In the Snowflake, count function can accept more than one argument. So that's the case where we're having here. So we have multiple columns being inputted as arguments. No matter is alias full stop, we call this fully qualified name, or we just use the column name directly. If there's no ambiguity, what is the result? And the last second, we're trying to make this thing more complicated. Since on the far right-hand side, you can see the duplication happened over 2 columns. So if we try to go over here, we try to distinct the column and then do a count, what would be the result? Likewise, we don't do the same thing for the column 2. And the last bit is try to say, if we try to do multiple columns with a distinct function, what kind of result going to produce from the code? Okay, let's just give you 5 seconds to think. You can also pause this video now and write down your answer. So the table we're going to use is on the right hand side like this way. So make sure you have a look of the table structure, column values, and then going back to this code to think about the result. Okay, so the naked run is done. Let's use the same code with some comments. In the SQL, when you try to write comments, what you do is use a double hyphen or dash, and then write a sentence on the same row. It will become grayed out area, which means when you control enter the whole script or use this run button, those comment lines won't be executed. So the first row we're trying to actually doing is that when you just use a star, which is this special sign in the count function without any prefix, instead you just do a basically row count. We can expect the result would be 9 because the row number is 9. Even we have some null values across these 2 columns. So it's disregard that. It's just talking about row count, nothing else. Second, when you use the star differently by attaching a prefix, for example, right now we're prefixing that with alias of the duplicates table, right? in that case, that star doesn't mean row count. It means that I will count everything but ignore all nulls. So ignore all nulls means that no matter the null present under which column, the whole row going to be discarded if there's a null present. So in this case, we can see that over here we have a null. This will be discarded definitely. This one will be this one, this one. So 4 rows going to be removed. So we're expecting 5 rows from this result. Okay, next bit is pretty easy, is normal the case that we're using. Just count, give me the count for a particular column, just one column. In this one column case, still the ignore feature of the count still works. It will ignore null based on the column that you provided. So for the column 1 here, it will ignore the 3 values. So I'm expecting return 6 rows from this count, right? For the column 2, I'm expecting removing this null and this null. Probably the result will be 7, right? Okay, let's move to the next. So in this case, we're using a fully qualified single column name. What is fully qualified? We know that in the database, especially in a relational database, when you're using SQL, the fully qualified names means that you have fully qualified path of your data object. Data object can be a table, database, schema, and also column. So when you use a fully qualified name, you normally nominate the full name of that. For example, you tell what's the table it's going to use. In this case, I'm using the duplicates, and also what's the column under that table I'm interested in. So in this case, I'm interested in the column 1. So that's a qualified, fully qualified name. You can make it better by just introduce more in the front for the database name. So with this qualified name, what kind of result are going to produce when we wrap it with the count function? Still, the ignore activity will happen. The last third is we try to do a count on multiple columns. Count on multiple columns normally will not work in any other SQL database, but in Snowflake it's different. It accepts multiple expressions. Expression just can be a column name. So in this case, it accepts 2 arguments, 2 expressions, 2 columns. We have column 1, column 2 being fitted as the arguments. In this case, it means that they will look at the concatenation of these 2 columns and then do a count. So still, the ignore activity will happen, which means all the nulls going to be removed before they do the count of the row. Likewise, for the fully qualified name, you will do the exact same. And then the second is we try to make the situation even more complicated by introducing the function distinct. So, like we said before, if you have a function wrapped within another function, the execution is going to happen from the internal to the external. So internal is distinct first. So we're going to think about distinct, the column 1 here. So distinct column 1, in this case, the null will be a valid value to be distincted. 3 nulls going to be distinct to just 1 null. And then the rest are going to do also the distinct. So 11 here appear 4 times, going to only count as 1. And also this 12 years, 13 years. So basically just return 4 rows with this distinct. And then wrapped with the count. Remember we said that only the first case, it will count null value. All the rest case when you're using the count function, it will ignore the nulls. So whenever the null presented, it will be ignored. So this is the case. Same as this one will be the same. The last 2 is we try to do count distinct on multiple columns. It's still the same. When we say that distinct on multiple columns, actually just looking at the combination of 2 columns or multiple columns, and then try to do a distinct. Once the distinct is done, even include the null value, then the count will be starting working and also try to ignore those nulls. So let's have this in our mind. We can run this query to produce the result. So the result is like this. Let's just have the solution like this as well. So I run this, but it's in a format like this. This is a little bit hard to read. So I just write down the solution on the far right hand side of each of the column. So let's just inspect the first one. Remember we said whenever you just use a star without any prefix, it means that it returns the row count of a particular data object. In this case, our data object is the duplicates table. So we're just saying return the row count of this duplicates table. By inspecting the structure of this table, we know that there's 9 rows. those null will be counted. So that's why it return 9. So here we can check that. That's the 9. Okay, let's move to the second one. So second one we're doing, just try to use the alias, full stop or star to say count what the result gonna be. So in this case, since you are not using the star solely, you are using it in conjunction with the alias, which is the table name. In that case, it will ignore all the nulls. This time it return 5s. So which 5 rows we're talking about? Actually, this will be removed because it has one null present and one column. Since we say ignore all the nulls, so this one will be removed. This one will be removed. This one will definitely be removed. And then this one will be removed. So what left with this is these 2 rows and these 3 rows. That's why when you try to use alias, full stop, and a star, it will return all the rows without a null and then doing the count. Next is the count just on a single column. In this case, the behavior is very predictable. We're saying just count on the column 1 and ignore the nulls. So in this case, we return actually the 6, which is correct for column 1. For column 2, we return 7 because out of these 9 rows, we have 1 null, 2 null. So 9 minus 2 equal to 7. Next, if we use the fully qualified, this can be skipped very quickly because they return the same result as we're just using the column name. So 6 and 7. So this is very simple to understand, very easy to comprehend. Next is we're going to say, what if we feed multiple columns? What the count function behavior will be. So in that case, we're looking at the result from these 2. So when you count on either the column name itself or the fully qualified name, it will return both 5. Why is that? So we're saying that when you move multiple columns into the count function, we're looking at the combination of these 2 columns together. So if I concat these 2 together, what will be the count result? So this will become a null, this will become a null, this will become a null, null, null. That's why the only return is these 2 rows and these 3 rows. That's why it's always 5, no matter you're using the fully qualified name or not. So the last second, we try to say, I not only want the column, but also I want the individual distinct value from the column and then do a count. So let's consider the first part, distinct. Distinct does not ignore nulls. Null is a legit value for a distinct. So that's why when we're doing the distinct column 1, it will have 1 null being preserved, 111 being preserved, 112 being preserved, 113 being preserved. Within these 4 rows, and we're going to do a count. Since a count, only the case it will not ignore the null is when you use a star, but this is not the case, right? So in this case, within these 4 values, what it will return a count is only 3. That's why if we move the result over here to check, that's 3, because it's only count 11, 12, and 13. So that's the result going to be last. Likewise for the column 2. So the first thing it want to do is try to do a distinct. You can see we have duplicated 101 here, 101 here. So in 2 together, it will have only 101, 102, and also a null value. And since 101 is already been preserved once, so this time it's going to be 103. So actually the result of this for the distinct is 101, 102, 103, and a null. And within these 4 values, we do a count, and the count ignored null, so that's why it's returned 3 result. Of the last bit is always return 4 for these 3 different count columns. Likewise, we did before, is always the combination. So when you combine things, column 1 and 2 together, in this case, if we say combine together, a null combined with another one will be a null. So this row, this row, this row, this row will all becoming null. In that case, if you try to distinct on this, we'll return 1 null. The rest going to be 11101, 11101, and 11102, and 12101, 13103. We can check that by simply try to do a count distinct, right? We just have this ready. So it's basically saying when you concat this 2, and then that's the concat value, and then we do a distinct. So that's the actual result going to be returned if you run this internally just for the distinct. So first it will concat this 2 and do a distinct. We can see that only 5 rows going to be returned. And then out of this, we do a count. That's why it's 4. So for this is 4 is because first it's look at a concatenation of this 2 column. I'm using this cast function to cast the column into a string because native is aligned to right hand side is a number. Concat only accept concat on string. So that's why I change the data type of the column. And then after I combine these 2 columns together, I'm using a distinct to return 5 rows. After 5 rows, I'm doing a count saying what's the value of that. Now it's return 4. So that's basically for this. This is likewise, combine every column together and then do a distinct and then do a count. So 3 actions. This one would be the same because right now we don't explicitly say which table, but here we only have one table from the front clause. That's why the star will present like the base full stop star, exactly the same. That's why when you run the query over here, the last 3 bit will return the same result as number 4 for the count. So that's pretty much for today's. If you want to have a chat with me, please ping with me about any doubt that you have. The count function can be very easy to understand, but sometimes when you add a different database, different platform, you may expect some unexpected result. That's pretty normal because not every platform accepts multiple values under the count function, but in the Snowflake especially, it accepted that and it produced a result which is making sense because in their article, they explicitly said that you can feed multiple value into that. If you have multiple columns into the count function, you can look at the combination of those columns and then produce the count. Like we said before, this case, this last 3 may be a little bit complex to understand. So feel free to pause the video and have a review again of the concept. But whenever you learn something, is always make sure that you're learning things on the relevant platform. For example, the count function has a different explanation across different SQL database. That's why you need to say, okay, I'm using a standard SQL based database. For example, Snowflake is standard SQL, or I'm using MySQL, Oracle SQL. There's many different type of SQL databases. So make sure that you're looking at the menu at the right place so you can produce the expected result with your data analytics. Okay, see you guys in the next one.